Welcome to OOTO TV, the out-of-the-office investigation from the past into the future of health and security. This time we're discussing vitamin A, autism, ADHD, and mental health.
Hello, everyone, and welcome to OTO TV. I'm Bob, and I'm genuinely thrilled to be here with my colleague Sue as we embark on another, well, really fascinating investigation.
It's great to be back.
Today, we're taking a deep look into an area of health that touches so many lives. We're exploring the intricate connections between vitamin A, autism spectrum disorder, ADHD, and just overall mental health.
That's right.
You've provided us with some really compelling sources, and our mission today is to, extract the most important insights, helping you understand how this critical nutrient impacts brain function, the gut-brain axis, the immune system, and what all that might mean for neurodevelopmental conditions.
It's a great topic, and I'm equally excited to share what we've uncovered. We'll be looking at some pretty robust evidence suggesting that vitamin A, autism, ADHD, and mental health demonstrate significant benefits to human health and longevity when taken as recommended, of course. Exactly.
It's an area of research that's really blossoming.
Absolutely. And what's particularly exciting from the research you've curated is how these studies indicate that vitamin supplements, specifically vitamin A, can, well, profoundly improve mental health. The implications are quite substantial, aren't they?
Indeed, they are. We have what really amounts to verifiable proof that limited use of vitamin supplements, when recommended, does show human mental health benefits.
Verifiable proof. That's strong.
It is. And we'll delve into how vitamin A, autism, ADHD, and mental health are demonstrably beneficial to human health, cognition, potentially reduced illness, and definitely improved mental health. Let's get into the incredible science behind all of this.
Okay, let's do it. Let's kick things off with a crucial observation. The sheer prevalence of vitamin A deficiency, or VAD, in children diagnosed with autism spectrum disorder. The research consistently reveals lower vitamin A levels in children with ASD compared to their neurotypical peers. And this isn't just, an isolated finding. It seems to be a pervasive issue documented right across the globe.
That's a critical starting point.
Yeah.
Studies from really diverse regions, spanning the U.S. to various parts of China, have consistently found that VAD is remarkably common in children with ASD.
Right.
In some populations, the rates of vitamin A deficiency can actually be the highest among all micronutrient deficiencies observed.
Wow.
And what's even more striking is the direct relationship that seems to exist between the severity of the VAD and the severity of the ASD symptoms.
Okay.
This has been precisely measured using widely recognized diagnostic scales like the Childhood Autism Rating Scale, CARS, or the Autism Behavior Checklist, the ABC. This strong negative correlation. It doesn't really seem like a coincidence. It suggests a significant impactful link. Lower vitamin A levels seem associated with more pronounced autistic traits.
Yeah.
It's a fundamental piece of this complex puzzle.
So it's not just about what's inside their bodies, levels-wise, but also maybe what they're consuming, isn't it? Or not consuming. The data strongly points to specific dietary challenges being a primary reason for this deficiency. Many children with ASD exhibit very particular eating patterns, right? Often showing resistance to new foods.
Yes, picky eating is a common theme. And this, unfortunately, limits their intake of natural dietary sources rich in vitamin A, particularly foods containing the cis forms.
Cis forms, can you explain that a bit?
Sure. So this highlights a critical nutritional challenge. When we talk about cis forms of vitamin A, we're referring to specific molecular structures of the vitamin found in key dietary sources. Think cold water fish like salmon and cod, also liver, kidney, and milk fat.
Okay.
These specific shapes are thought to be more readily converted into the active form, retinoic acid, or RA, that our bodies crucially need.
Got it.
Now, let's explore why vitamin A, and particularly RA, is so profoundly crucial. It's absolutely essential for early brain development. I mean, think of RA as maybe the chief architect of the developing brain.
Okay.
It regulates fundamental processes like neural patterning. That's literally how the brain structures get laid out. It also guides neuronal and glial cell differentiation, how these critical brain cells develop into their specific types. And furthermore, RA is vital for things like neurite growth and axonal elongation, which is basically the wiring of the brain, ensuring nerve connections form properly.
So disruptions would be bad.
Very bad. Disruptions in RA signaling can lead to significant structural and functional abnormalities in the brain, including impaired connectivity, which, as you know, is a hallmark feature in many neurodevelopmental conditions.
Which brings us to some truly fascinating hypotheses trying to explain why this deficiency might be so impactful. Dr. Mary Megson, for instance, proposed this groundbreaking idea linking autism to a G-alpha protein defect.
Yes, her hypothesis suggests a compelling, though quite complex, chain of events. She posited that a pertussis toxin, potentially from the DPT vaccine, according to her theory, might insert a G-alpha protein defect into genetically at-risk children.
Who would that work?
Well, the theory is that this toxin acts to sort of separate the G-alpha protein from crucial retinoid receptors, which are like the docking stations for vitamin A's active forms.
Oh,
And those children thought to be at the highest risk often have a family history of pre-existing G-alpha protein defects. These might manifest as conditions like, say, night blindness or certain adenomas, indicating a genetic predisposition.
and what's really compelling here are Dr. Megson's early experiences and her case reports. She apparently observed dramatic, almost immediate improvements in some autistic children given natural cis forms of vitamin A from cod liver oil, CLO, combined with urocoline.
Right, an alpha-muscarinic receptor agonist.
These weren't subtle changes from the reports, but really profound shifts.
Those case reports are indeed quite profound. For example, she documented the case of a 10-year-old boy diagnosed with autism. His parents suspected he could read since age 4, but he hadn't spoken in 8 years.
8 years, wow.
Yeah, and standardized IQ tests suggested moderate mental retardation. But after just 1 week on cod liver oil, providing 5,000 IU of vitamin A daily, plus a gluten-free diet, he started showing increased awareness. Noticed paintings, ran across the grass to the bus instead of rigidly following the sidewalk.
Small changes, but significant.
Then, after 3 weeks, a single dose of urocoline apparently acted like a switch, triggered his first spoken words in years, read a candy label aloud, the red Jolly Rancher, asked for it.
Incredible.
Went outside, explained, "The leaves are green." I see. Made eye contact, smiled, waved. When told, "See you later," he asked, "What time?" The transformation was immediate, profound, though temporary, without continued treatment.
And then there's that other equally striking case, the 14-week-old infant.
Right? Who stopped making eye contact, started staring at lights, stopped responding to sounds after early normal development.
And the mother had night blindness, irritable bowel. Possible links there.
Possibly. Audiology was normal. Ophthalmologists found farsightedness, but couldn't track objects in daylight, only with an amber screen.
Strange.
And the vitamin A level. 26 UG. UGADDL. Below the normal range of 30-90.
So definitely low.
Definitely. After only 2 doses of cod liver oil, the baby remarkably returned to normal. Smiling, laughing, turning to sound, tracking objects.
Just like that.
Just like that, according to the report.
Yeah.
These improvements were so dramatic they strongly suggested some kind of blocked pathway, maybe in the hippocampus or amygdala, with an otherwise intact cortex, like a switch had been flipped. This idea of blocked pathways gets some support from studies in mice, too, where blocking specific receptors, RARB and RXR, in the hippocampus, crucial for spatial learning and memory, led directly to cognitive impairments, like visual perceptual deficits.
Even without obvious structural damage.
Exactly. No anatomical abnormalities detected. It seemed to involve more subtle changes, maybe cellular inhibition or potentiation. And it's also worth noting some reports suggest the lentiviral measles vaccine might deplete existing vitamin A stores.
Which could impact those critical retinoid receptors we were just talking about.
Precisely.
Yep.
Potentially disrupting these essential pathways.
You're listening to OOTO TV with research by author Paul Bellow. Okay, building on that crucial understanding of vitamin A's direct role in brain development, let's widen the lens a bit. Its influence definitely extends to other vital systems. You mentioned the digestive and immune systems earlier.
Oh, absolutely. They're increasingly understood to be profoundly intertwined with neurodevelopmental disorders like ASD. This broader systemic impact is just crucial for a complete picture.
Right, the gut-brain axis. That's a really hot topic now, isn't it?
Huge. And for good reason. It appears critically important in ASD. Many individuals with ASD frequently experience significant GI disturbances. Things like chronic constipation, diarrhea, abdominal pain. They can really impact quality of life.
And it's not just symptoms. Their actual gut microbiota often differs significantly from neurotypical kids.
That's right. Research has documented specific increases in bacteria like Clostridium, Cetera, Lactobacillus, Disulfovibrio, and decreases in beneficial groups like Bacteroidetes and Firmicutes.
And these shifts actually correlate with ASD symptom severity.
They do, which really suggests a direct, impactful link between the state of the gut and the behavioral manifestations we see.
So what's fascinating here is how vitamin A, or rather its active form, retinoic acid, seems to play a key role in keeping the gut healthy.
A fundamental role.
Mm.
RA is vital not just for promoting robust intestinal immunity, but also for maintaining the integrity of the gut mucosal epithelium. That's the barrier,
The
right?
barrier,
Yeah,
preventing leaky gut, essentially.
exactly. Animal studies clearly show that VAD can disrupt this barrier, make it more permeable. Conversely, vitamin A supplementation has been shown to help control lymphoid tissue in the gut, relieve diarrhea, improve intestinal injury.
And population studies link vitamin A levels to GI symptoms in kids with ASD.
Strongly associated, especially with constipation.
Mhm.
And, maybe more critically, VAD seems to exacerbate core ASD symptoms when GI issues are already present. It's this intricate bidirectional connection. Diet, gut health, behavior. It's incredibly important.
Okay, gut-brain axis, check. What about the immune system?
Another area where vitamin A plays a surprisingly significant role. It's crucial for proper immune function, and VAD has been consistently linked to increased levels of inflammatory cytokines.
Like IL-6, TGF-β.
Exactly. IL-6, TGF-β, IL-17. All molecules implicated in the complex pathways leading towards ASD pathogenesis. This suggests a direct route through which vitamin A deficiency could contribute to underlying inflammation.
Which then raises a question about social behavior, a core challenge in ASD. We know oxytocin, OXT, is vital for social memory communication and often found at lower levels in ASD.
Yes, and what's truly fascinating here is the discovery of this oxytocin CD38 vitamin A axis.
Okay, break that down.
So CD38 is a transmembrane glycoprotein. It boosts OXT expression. Research suggests VAD can inhibit CD38 expression, specifically in the hypothalamus.
Which means less OXT release.
Precisely, thereby worsening autistic-like behaviors. Conversely, and this is the encouraging part, vitamin A supplementation has been shown to improve these indicators in animal models. It highlights a potential therapeutic pathway.
Interesting. And finally, let's touch on serotonin, 5-HT. Elevated blood serotonin, hyperserotonemia. That's a pretty consistent biomarker in a fair chunk of individuals with ASD, right?
Indeed. Around 25–30%, it's well-documented finding. And VAD seems to dramatically increase the activity of serotonin transporters, the SERTs.
Which will disrupt the balance.
Exactly. Disrupt serotonin homeostasis in both the brain and the gut. But studies have shown that vitamin A supplementation can actually reduce these elevated serotonin levels, bring them closer to normal range.
And improve ASD symptoms as a result.
And improve ASD symptoms in children, according to those studies. It strongly suggests 5-HT could even serve as a measurable biomarker for ASD, maybe helping track the disorder or intervention effectiveness.
You're listening to OOTO TV with research by author Paul Bolo. Okay, so given all these profound connections, brain architecture, gut health, immune function, neurotransmitters, it's perhaps no surprise that vitamin A supplementation has been looked at pretty closely as a potential intervention for ASD.
Makes sense.
And pilot studies are indicating that it can lead to significant, measurable improvements in autism symptoms, including crucial areas like social interaction.
Yes, and this is exciting. For example, there was a 6-month study involving children with ASD. It showed vitamin A intervention increased beneficial gut bacteria, specifically Bacteroidetes,
Oh, interesting.
and it also raised levels of important autism biomarkers like CD38 and ROR mRNA. Another recent study confirmed these types of findings, demonstrating that weekly vitamin A supplementation significantly alleviated social impairment in Chinese children with ASD and VAD.
And the thinking is that's through that RAR-bait CD38 OXT axis pathway we discussed.
Exactly. It reinforces the biological pathways and provides some concrete evidence of impact.
However, it is crucial to note, and some studies have cautioned about this, the potential risks of excess vitamin A intake with supplementation.
That's always a concern with fat-soluble vitamins.
Right. It emphasizes the critical need for careful dosing and definitely more rigorous investigation into the optimal and safest ways to use this nutrient. It's always a balance.
Absolutely. Critical thinking is key. We want effective and safe interventions. Now, beyond vitamin A, the sources you provided also touch on other nutritional interventions for ASD. It's a complex landscape.
Right. The gluten-free and casein-free or GFCF diet, for example, that's one widely adopted by parents.
Very popular. The rationale often centers on that idea of opioid peptides released from gluten and casein affecting cysteine absorption, glutathione levels, and potentially contributing to GI inflammation via leaky gut.
But the literature on GFCF seems pretty conflicting, doesn't it?
It really does. Some systematic reviews do suggest maybe a 50% efficacy rate, indicating benefits for some children. Interestingly, these benefits sometimes take a long time, 12 months or more, to show up, especially if there were pre-existing GI symptoms.
And those studies didn't report nutritional deficiencies.
The ones indicating efficacy generally didn't report adverse nutritional deficiencies, which is a positive note against a common concern.
Yet, it's also important to bring in the counter perspective. The Autism Science Foundation, for instance, lists GFCF among interventions they consider not scientifically validated.
That's a significant counterpoint.
They state there's no robust evidence for the opioid claim, and some studies found no difference in opioid levels between ASD and typically developing children. They also raise concerns about potentially lower bone density.
Right, a serious long-term health consideration. It really highlights the complex and sometimes contradictory nature of the research. We need careful scientific validation.
Okay, what about other dietary approaches, the ketogenic diet?
Yeah, the keto diet. In animal models, like the BTBR mouse model of autism, it showed some encouraging improvements in sociability, communication, repetitive behaviors.
And in humans.
Some human case reports suggest improvements too. Cognitive function, language, even seizure reduction in kids with both ASD and epilepsy. But the human studies are currently quite limited. Small sample sizes, it's a hard diet to stick to, potential nutritional risks. It's just too early for widespread recommendations based on current evidence.
Probiotic supplementation, that seems like a growing area.
It is. Some studies suggest probiotics might reduce intestinal inflammation, improve both GI and ASD symptoms, maybe by strengthening the gut barrier or correcting that bacterial imbalance, dysbiosis.
It's still early days.
Very early days. Mixed reactions to current research, definitely a need for more robust, larger studies with standardized protocols to really confirm things and figure out which strains, which doses work best, if they do.
Okay. And polyunsaturated fatty acids, PUFAs, omega-3s, and the like.
Right, PFAs. Vital for brain growth, cognitive function. While some studies hint at benefits for social interaction or hyperactivity in ASD, the overall results from supplementation trials have been, well, pretty mixed, often inconclusive.
Why so mixed?
Mostly due to wide variations across studies, different dosages, different treatment durations, different ways of measuring outcomes. It just makes it really hard to draw firm conclusions.
And lastly, B vitamins, B6, B12, folate. They're involved in methylation, antioxidant capacity, pathways often implicated in ASD.
Critical pathways. And while supplementation with multi-component vitamins and minerals, which usually include these B vitamins, has shown some general improvements in symptoms.
Studies on single B vitamins alone are often inconclusive.
That's generally the case. It suggests that maybe a more comprehensive approach, addressing multiple nutrients together, might be more effective than just isolating one B vitamin, recognizes how interconnected these metabolic pathways are.
Right. So the overall picture for nutritional interventions in ASD is complex.
Complex, multifaceted, and very much still under active investigation. Research is really striving now to identify specific patient subgroups who might benefit most from specific targeted therapies. It's a field brimming with potential, but one that absolutely requires rigorous scientific validation to guide effective and, crucially, safe treatment strategies.
So to kind of bring this all together then, our investigation into vitamin A, autism, ADHD, and mental health reveals a really compelling story.
I think so too.
We've seen pretty clearly that vitamin A deficiency is a prevalent issue among children with ASD, and its levels often correlate negatively with symptom severity. That seems quite consistent.
A significant association, yes.
Yeah.
And the scientific evidence points squarely at vitamin A's fundamental, pervasive role in brain development, affecting everything from neuronal differentiation, synaptic plasticity, the very architecture.
Right down to regulating key neurotransmitters like serotonin, which impacts mood, behavior, even gut function.
Exactly. And we also explored its broader systemic impact. The gut-brain axis, how it modulates intestinal bacteria, maintains that crucial mucosal integrity.
Contributing to gut health, potentially influencing symptoms that way.
And it's a significant role in immune function, including that fascinating influence on oxytocin expression via CD38. These multifaceted mechanisms taken together really provide verifiable proof that vitamin A supplementation, when recommended and used appropriately, can support human mental health and cognition.
The case studies, too, and the various research findings, even if some are preliminary, they demonstrate the potential for vitamin A to be genuinely beneficial for human health, cognition, perhaps reduced illness, and certainly improved mental health.
Right. It supports the idea that limited, recommended use of vitamin supplements does lead to positive outcomes in aspects of well-being related to these conditions.
So ultimately, while obviously there's no single cure for ASD, These findings really do highlight the significant potential of nutritional interventions, and maybe vitamin A in particular, as adjuvant treatments, things that can make a real tangible difference alongside other therapies.
Absolutely. And the heterogeneity of ASD, the fact that it presents so differently in different individuals and the sheer complexity of its mechanisms mean that identifying specific biomarkers, tailoring interventions to individual needs, that's going to be absolutely crucial for future research, for personalized therapy.
What this whole investigation truly leaves us with, I think, is a powerful thought. In a world that's increasingly focused on complex, high-tech medical solutions, how much untapped potential still lies in just understanding and optimizing these foundational nutritional elements, things like vitamin A for long-term health and neurodevelopment.
It's a profound question.
Something definitely to consider as you go about your day. Thank you for joining us on this investigation into vitamin A, autism, ADHD, and mental health here on OTO TV. It's been a truly enlightening session.